All right, pre-calculus, here we are. This is the first pre-calculus video on Yak Math Videos. This year, we are brought to you by proud sponsors, RX Bar, Laura Bar, Bobo's, PB&J, little soft baked sandwiches, gluten-free, Bodies It Simple. We also have literary sponsors today. The Greatest American Poets, ooh, very good. And The Obstacles the Way, quite stoic there. All right, folks, we are excited for another season of math. Here's the chapter 1 quiz review video for pre-calculus. Folks, pre-calculus quiz is going to have 15 questions. You're going to have one difference quotient, one graph, 4 domain questions among those 15. All right, so 1 and 2, determine whether each relation represents a function. If it is a function, state the domain and the range. First off, the domain, that's all the x values. -1, 2, 4. They are already in order. -1, 2, 4, set notation. And then the range is all the y values, 0, 3, 0. I said 0 twice, just write it once, 0, 3. Please put them in order. Now, to be a function, you can't have any cheating x's. I did not say the same x value twice. Therefore, it is a function, all right? Then on number 2, let's take a look at the y values. I have 4, 2, and 4. So first off, it's not a function. If it's not a function, we're not stating the domain and the range. So that's it. We simply say not a function, done. But you got to be real careful on that. All right. Let's take a look at here. 3A. Might have to move our sponsors back. 3. All right. We're going to find, given f of x is 3x over x squared minus 1. We're going to find f of 2. That just simply means plug 2 in for x. Plug 2 in for x there and there. So it's 3 times 2 over 2 squared minus 1. And we get 2. All right, easy peasy, hopefully. Then we have f of -2. 3 times -2 all over -2 squared minus 1. I square a negative, it's always positive. All right, so we got opposite answers there. Interesting. All right, and then we have C. C says f of -x. So I plug -x in for x. Okay, 3 times -x is -3x. If I square -x, I still get x squared minus 1. Then last I have f of x minus 2. That is 3 times what I'm plugging in for x over what I'm plugging in for x squared. Okay, so up top it's 3 times x minus 2. Down below it's x minus 2 all of it squared. Again, I take this first term x and I square it. Use the same sign here, minus. I take that inner product, which is x times 2 or 2x, and I always double it. That's why I have a minus 4x. Again, if off to the side, you need to actually FOIL it. That's fine, but we want to have this trick down. Then ultimately off to the side, I'm going to subtract 1. When I square a -2, I get a positive 4. And that cut off, but the denominator is going to be x squared minus 4x plus 3. All right. Now this next one says, again, pause this video whenever you need to, go back. Can't make 40-minute videos all year. Let's take a look here. Should have been better prepared for this. But number 4, here is number 4. All right, we did do it in class, but let's talk about it again right here. It's the purpose of this video. Given f of x is the square root of x squared minus 4, we're going to plug 2 in for x and get the square root of 0, which is 0. We're going to plug -2 in for x and get 4 minus 4, which is the square root of 0, which is also 0. Plug in the opposite of x, and then I get x squared minus 4 inside the square root again, and then I'm going to plug x minus 2 in for x. I'm going to square it. Again, I take the first term x and I square it. The inner product here is 2x. I double it. I bring down that negative. It's the same sign. I take -2 and I square it to get positive 4. Then I'm going to subtract 4, right, because it's x squared minus 4. That gives me x squared minus 4x inside the square root. All right. Then that brings us to 5, and we're doing the same thing, f of 2. So you might have 1 or 2 of these. You're not going to have 3 for sure. I'm going to plug 2 in for x there and there. All right, so 2 times 2 squared minus 4 times 2 plus 1. And I get 1. Then we'll plug in -2 in for x. 2 times -2 squared minus 4 times -2 plus 1. 8 plus 8, which is 17. Or 8 plus 8 plus 1, which is 17. Then f of -x, 2 times -x squared minus 4 times -x plus 1. A negative times a negative is a positive. -x squared is positive x squared. All right, and then I have f of x minus 2. 2 times x minus 2, all of it squared, minus 4 times x minus 2 plus 1. So we've done x minus 2 squared like several times here now. That's how it foils out. -4x plus 8. A negative times a negative is a positive 8. All right, I'm going to distribute 2x squared minus 4x plus 8 minus 4x plus 9, 8 plus 1. All right, that gives me 17. Underline the like terms there, -12x, and I got that 2x squared out front. All right, so as I said before, looks like you're gonna have 4 of these questions. 4 domain questions, that's quite a bit. So, find the domain of each function. First off, you got a rational function. That's a fraction. In a fraction, you can't divide by 0. So we simply set the denominator equal to 0. Get x squared equals 9. X is plus or minus 3. It means x is not allowed to equal plus or minus 3. We write the domain as x such that x can equal plus or minus 3. Want that to be a slam dunk. All right? And honestly, it's the same thing as 8. So 6 and 8, basically the same questions. Again, I don't care about the numerator. The numerator can be 0. That's the x-intercept. I simply set x squared plus 2x minus 3 equal to 0. I factor this. X plus 3x minus 1 equals 0. So that tells me that x can't be -3 because the denominator is 0. X also can't be 1. And that's how I write it. I put it in order. I can use set notation for that. Okay, then comes 7. 7 would be, I guess, the next challenging one. You are allowed to have the square root of 0, but remember, a square root of a negative number is undefined. All right, so I set what's inside the square root equal to 0. I get x is 2. Now be careful. If I plug a 3 in for x, I get a square root of a negative, which is not allowed. So it's actually got to be, x can be any number 2 or less. So you could have written it like that in college algebra and algebra 1. How do you write it like, you're not going to use, so how are you going to write this here in pre-calculus? You're not going to use set notation. Set notation is good for like what x can't equal. X can be anything as long as it's not this 1 or these 2 or even these 3 numbers. So x is less than or equal to 2 means 2 is the highest number. Less than or equal to means I use a bracket because I can have it. It includes 2. And I'm going south. It can be 0, it can be -10, it can be -1,000,000, it can be a -1,000,000,000. It's going all the way towards negative infinity. You always use a parenthesis around infinity or negative infinity. All right, so I want to practice a few more of those. That's this section's going to have a few that are a little interesting for us. All right, like number 9. Okay, so first up, can't divide by 0. So you set the denominator equal to 0. So we know that x squared minus 4 equals 0. X squared is equal to 4. X equals plus or minus 2. So we know that x can't equal plus or minus 2. Good to know. Then also I can have the square root of 0, right? So I set x plus 1 equal to 0. I get x equals -1. Now again, I can't have the square root of a negative. So x can be any number, -1 or bigger. I could plug 0 in for x, 1 in for x, 3 in for x, 1,000,000, 1,000,000,000, all that. So x has to be greater than or equal to -1, and it can't be plus or minus 2. So yeah, this one might be on the more interesting side as well. So what does it mean to be greater than or equal to -1, but I can't be plus or minus 2? We're going to use interval notation here. Greater than or equal to -1 means -1 is my lowest number. So I don't have to worry about this -2 because it has to be greater than -1. So use a bracket around -1, comma 2. I use a parenthesis around 2 because it's allowed to get really, really close to 2, but it can't be 2. And then I say and parenthesis any number 2 or more. So any number -1 to 2, not including 2, union any number just bigger than 2 to infinity. That's what we're saying there. Okay. That's 9 and 10. I would expect one like 9 and 10. You're not going to get both, but one like 9 and 10. My goodness. Those would be on the more interesting side for sure. So just like number 9, well, really, no, you just said, I'm sorry, number 9 is similar to 7. All right, so first off, I don't care about the numerator. I set the square root of x plus 8 equal to 0. All right, so I said x plus 8 equal to 0. I get x equals -8. Now, you can't divide by 0. So x is actually not allowed to be -8. Also, the square root of a negative is undefined. So x isn't allowed to be -8 because then you would be dividing by 0. So that's what's different than 7. See, 7, this wasn't in the denominator. So it can't divide by 0. So x is not allowed to be -8. And also it's a square root function, so x has to be bigger than -8. So what does it mean to be bigger than -8, but it can't exactly be -8? Well, it's this right here. What in the world? Someone had a massive brain fart when writing that out. In fact, guys, did we talk about this in class? I don't know if we talked about this one in class. X is greater than -8. This is, yeah, that's not true, or what I wrote. So x has to be bigger than -8. So -8 on the low end, right? Parenthesis, because it can't be -8, and it's going towards infinity. All right. So I forget if someone asked me about that, but this is definitely it. What it means to be greater than -8. All right. Let's talk about 11. Find f of g, f minus g, f times g, f divided by g, and state the domain. This would be a pretty easy question to get. All right, so this is f of x plus g of x, and you just underline like terms. Get 2x plus 3. What's f minus g of x? You got to make sure to put g of x in parentheses. -x minus 3x is -4x. 2 minus 1 is a +1. All right, f times g of x, you multiply. Some of us, you got to multiply it all out and simplify, all right? Some of us may have got that wrong on our in-class assignment. Just FOIL. 6x plus 2 minus 3x squared minus x, and simplify that. All right, then f of x divided by g of x is simply this. You got to state the domain. I said 3x plus 1 equal to 0. I don't really show much work here. I get x equals -1/3. That means the domain is any x such that x can't be -1/3. All right, we talked about 12 in class. F plus c, I take this plus this. That's pretty easy. F minus g, I take this minus this. X minus 2x. So -x, that should be pretty easy. Then I have f times g. Just do distribution, 6x to the third, 2x squared, 2x. Lastly, I have f divided by g. All right, then I set 2x equal to 0. I get the domain is any x such that x doesn't equal 0. All right, folks, now we're feeling good. That is an easier question. 13, we did a good job on our in-class assignment on the difference quotient, but we also had notes with it. So this is going to be one we practice together. This one's would be a little bit more challenging with that whole negative. All right, but I have to give you the difference quotient. All right, so what is f of x plus h? That means I plug x plus h in for x here and here. And then I add 2, and then I subtract f of x. Well, you're given f of x, so just put it in parentheses. All right, so I'm going to take the first term, x, and square it, plus the inner product is xh So I double the inner product. I'm going to square h plus 3x plus h plus 2. Then to subtract a negative is to add. To subtract 3x, to subtract 2. All right, then I distribute. I'm multiplying by negative 2. Okay. Then I didn't cancel anything yet. And now it's time to, again, take your time. Pause this if you need to. Now it's time to cancel. All right, so negative 2x squared with 2x squared. 3x, negative 3x, 2 and 2. Then I'm left with negative 4xh minus 2x squared plus 3h over h. And I divide everything by h. Notice how everything that didn't have an h got canceled. That's very, very important. Okay. Then we have 14 through 16. Show whether each function is even, odd, or neither. Okay, again, I'm going to let you just take the easy approach here and plug in opposites. We really want to get these right. So first off, I'm looking at the exponents. I don't see anything odd, right? So this can't be odd. It's a good chance this bad boy is going to be even or nothing, right? So I plug negative 2 in for x. I get 8 over 17. That's a weird answer, but it's fine. Then I plug 2 in for x, because I plug in opposites. So you can plug negative 2, positive 2, negative 3, 3, even negative 1, 1. That's fine. All right, then I get 8 over 17. So I get the same answer. So it's even. Also, if you plug negative x in, you get the same answer as f of x. That's the proper definition. All right, so on 15, what's f of negative 2? I plug negative 2 in for x there and there. Just be careful with the cube and a negative. Then I plug 2 in for x. Okay, I get negative 6 and positive 6. Opposite answers means f of x is odd. F of x is odd. And then, like, here's another way. If you plug in negative x, you get the opposite of f of x. Again, that's the proper way. Then we have 16. It's set in class. So I'm going to give you the answer right here. All right, 16. I think I had a brain fart. So I plug negative 2 in for x here and here. All right, I get 16 minus 12, ultimately plus 7, which is 11. Then I plug 2 in for x here and here. Get 16 minus 12, ultimately plus 7. F of x is even. You get the same answer, f of x is even. Okay, then we're going to 17. Find the average rate of change, guys. This one you want to be easy. So it is literally f of 2 minus f of 1 all over 2 minus 1. All right, it's slope. F of 2, you plug 2 in for x. F of 1, you plug 1 in for x. All right. F of 2 is 30. F of 1, 7. 30 minus 7 over 2 minus 1. It's 23 over 1, which is 23. Man. All right, so the rate of change here would be f of 4 minus f of 2 all over the x value 4 minus 2. Plug 4 in for x right there and there. And I get 128 minus 4. Plug 2 in for x. I get 100. Oh, I do not get 100. I get 32 minus 2, which is 30. So 124 minus 30, 94, all over 2, it's 47. You can get a negative. All right. Let's go. 18. 18 was in class. What's going to happen here? So I'd expect one of these. This is not a hard question. So again, it's f of 3 minus f of 2 all over 3 minus 2. F of 3, I plug 3 in for x there and there. Get negative 27. F of 2, I plug 2 in for x there and there. And I get negative 10. So it's negative 27 minus negative 10 all over 3 minus 2. And now I have my rate of change, or my slope, of negative 17. Then I'm going from 3 to 5. So it's f of 5 minus f of 3 over 5 minus 3. I figure out what f of 5 is. I plug 5 in for x there and there. I plug 3 in for x there and there. Feeling pretty good about negative 85 and negative 27. So negative 85 minus negative 27 all over 5 minus 3, which is 2. And that's negative 29. All right, pause that if you need, but this video is not gonna be short. All right. Let's talk about 19 and 20 real quick. Graph each function. All right, so we have 2 pieces, and both pieces are straight lines. This is straight from college algebra. So negative 2 to 2, so I'm going to use both. All right, it's a straight line. I just need 2 points. I got a lower bound, upper bound. I use negative 2 and I use 1. I plug negative 2 in for x. I plug 1 in for x. Now, negative 2 is less than x. That is an open circle. X is less than or equal to 1. That's a closed circle. So open circle at negative 2, negative 6, and closed circle at 1, 3. That's my first line. It looks like a little barbell that's been tilted. My second line, it's x is greater than 1. So I do use 1. Remember, that's a transition point. I always use that. Now it's an open circle. Plug 1 in for x, I get 2. And then, I can plug 2 in for x. I can plug 3. Plug 2 in for x, and I get 3. This is another straight line. Y equals mx plus b. 2 points to determine a line. That's an open circle at 1, 2. And then 2, 3. And it's going to go like that. All right. It looks, my graph's not great, but they do miss each other there. Okay, that one's not too bad. You would have done that one last year in college algebra. Then I have x is less than negative 1. X is greater than or equal to negative 1. This is piece 1. This is piece 2. All right, less than negative 1. I use negative 1, but it's an open circle. Just be careful. What's another point less than negative 1? Negative 2. Plug negative 1 in for x. I get negative 1. I plug negative 2 in for x. I get negative 3. Then x is greater than or equal to negative 1. Negative 1's that transition point. Closed circle at negative 1. Plug negative 1 for x. What is greater than negative 1? How about 0? Plug 0 in for x. And I get negative 4. All right, so this first one, negative 1, open circle. Negative 2, negative 3, and the line just goes down. Sorry, line just goes down. Next one, negative 1, negative 5. That's a closed circle. Then I have 0, negative 4, straight line, and that line just goes up. Okay. You're going to have one of those. And then lastly, folks, I'd expect something like this. Consider the function, piecewise function, 3 parts. Hopefully the last one there. What's f of negative 1? When is x allowed to be negative 1? The third part. X is greater than negative 2. So I plug negative 1 in right there. I get 5. When is x allowed to be negative 2? Only there. If x equals negative 2, exactly, then your value is 4. So it's the second piece. F of negative 3. When is x allowed to be negative 3? When negative 3 is less than negative 2. So that first part, plug negative 3 in for x there and there. I use this first equation, and I get 15. All right, we want to handle that one well. That one should also be on the easier side. And then, 22, just kind of want to throw in there, find the domain of. You're allowed to take the square root of 0, so we set this equal to 0. We had 4/5. And again, just be careful. 4/5 is close to 1. If I plug 1 in for x, 1 would be bigger. So if you have a minus x on the inside, then that's going to be the highest value if you guys are catching on to something. If I plug 1 in for x, then I get the square root of negative 1, which is undefined. So it has to be, it can't be, 1, it can't be 2, it can't be 3. So it's got to be less than or equal to 4/5. 4/5 is the highest value of x you could plug in. So what does it mean to be less than or equal to 4/5? It means 4/5 is the highest number. Again, you're allowed to take the square root of 0, so that's why I use a bracket. So it can be 4/5, it can be 0, it can be negative 1, it can be negative 2, it can be negative a million, a negative billion. You get the point. Going down to negative infinity, always parentheses around negative infinity. And then what's f of -1? Plug -1 in for x. So -5 times -1 is a +5. 4 plus 5 is 9. The score to 9 is 3. 15 questions. So that means 7 of these didn't make the cut. 1 difference quotient. Difference quotient made the cut. 1 of those 2 graphs, something like it, and 4 domain questions. Folks, we can do well. This is Yak Math Videos signing out.